All right, so we're getting into Unit 2 now, and Unit 2 is I realize I have to organize the Blackboard, this folder a little bit. My Unit 3, 4, and 5 are good, but we're getting to Unit 2, which is now the rest of Chapter 1, which is a skeletal system, and then we're getting to Chapter 2, which is neuromuscular. If you've taken KIN 230 or taking it or are going to take it, there's a little overlap here. KIN 230, we get more really into the physiological process of like muscle contraction and neurological conduction and the impacts for that. For this class, we're just looking at more of the structural component related to movement. So some of the things we don't cover in 230 are like dermatomes and myotomes, so like the spinal level that connect to the certain sensory input and motor output. So we talk about that in this class. And in some functional anatomy classes, they really get into like the neural innervation to the muscle. So like not only do we know that the bicep is doing elbow flexion and it's part of the long head bicep, short head bicep, but then what nerve root is controlling that movement? I think that's covered almost exhaustively in your structural anatomy class or your bio 160 and so forth. So we don't get into that so much. What I do want you to know and start thinking in this class is like general neuro aspects. So like just know that C5, C6 kind of controls the elbow flexors, but to know exactly which nerve and nerve root, you're going to get that in your anatomy class. The real focus of this understanding, and particularly this unit, which is going to be big in the next three, can you delineate between concentric muscle function and eccentric muscle function? Because what's going to happen is in anatomy, and you probably know now, you learn muscles from this like cadaver position, right? Anatomical position, and you learn muscles exclusively in their concentric function. So you know that biceps, long head, does elbow flexion. More than 50%, I would say 70, 80%, now that's just my own arbitrary aspect, of muscle function, of our functional aspect, movement, real life situations occur in the eccentric, not creating force, accelerating, but decelerating, right? And it's not going to be covered in this unit. We'll get it in Unit 4 when we get to lower extremity. But like when we look at our internal rotation of our hips, right? We look at the number of muscles that exist to do internal hip rotation. So let's say you want to pigeon toe, you're going to turn your toes in. We don't have any muscles that directly do that, right? Because we don't do it often because gravity does it for us. We spend so much time trying to resist gravity that we've really developed the control of internal rotation as more of an eccentric function. So your big hip muscles like your glute max, which concentrically you learn those as external hip rotators, they are the ones that are counteracting gravity for internal rotation. So we have a lot of anti-gravity type situations where our muscles are doing a lot of the work. And that's what really gets into functional anatomy is like when you bend down to touch your toes, you are doing trunk flexion, but your trunk flexors aren't working at all. It's all your hip extensors, back extensors that are slowing you down so you don't crash face first into the ground. So when you start getting into your personal training, physical therapy, athletic training, any of the careers, chiropractic, whatever career you're going to go into, when you start looking at like, why is that tissue beat up? Why do I need to adjust that joint? Why is that tissue tight and I need to stretch it? You need to break free from the, oh, okay, well, it's the concentric function. Well, you need to evaluate the eccentric function. And I would probably lean more towards like the way I think clinically, I'm always thinking eccentric function first because that's where it's the hardest stress on the tissue, the most amount of activity that we need to do, and usually when we have the overuse issues. So that's where we're going with this unit 2 is can you delineate between, joint movement, and that's a concentric activity, or joint movement, and that's an eccentric activity. So it's taking what we've learned in unit 1 and just adding a new step to it. So what you'll find in the Unit 2 folder is you're going to find, same thing, you'll see like the extra credit crosswords and the model exams. I have some artifacts here. It's like some stuff you'll see on my screen because it's hidden, it's the instructor view, but it's your view is going to start right here. It's going to be like these basic facts, and you're going to have the skeleton worksheet and then the muscle worksheet. And the skeleton worksheet and muscle worksheet are a little misleading. It's just to get you familiar with like what the femur is and what the scapula is and because we're going to be using those terms. So we're also going to continue using our terms of anterior, posterior, medial, lateral, but I'm going to try to use anatomical terms as much as I can. I'll always preface with like shoulder, but there's really no such thing as the shoulder joint, right? It's the glenohumeral joint. It's the humerus meeting the glenoid fossa of a scapula. The ankle. So it's just getting familiar with the bones. You should know about 80 to 90% of these bones are muscles. off the top of your head. I'm not going to test you in that, and you'll always be able to look it up, but it would be helpful for you as we go through lectures, as we go through talks or discussions, as you go through reading, that you know where the femur is at, where you know where the tibia is at, where you know where the fibula is at, just basic orientation to the body. Then I have a little video here. This is an artifact from a previous class that I used to do before I did all the videos, but I just gave it was a quick, concise, and you can see that I pilfered some of these images, and it's an Australian guy, so you get to get a different accent instead of me all the time. He might be New Zealand, but he won't get mad at me if I call one or the other. But it's a little 7-minute video that goes through just concentric, eccentric, a good little review video. And then I have 4 lecture videos here that are somewhat, I mean, some of them are like, yeah, they're long, like but they're in depth. I think this one's like 9 minutes. I think that one's the longest one, and this one's about 11 minutes. Okay, yeah. And then I got one more here. Perfect. Okay, so this is the long one, like muscle contraction and gravity. And this is the types of muscle contraction. These are great. Like I just did these videos last semester, and it made a big difference in people's understanding of concentric, eccentric. So go through these videos. What I haven't uploaded yet, which I will do either later today or tomorrow, I'll upload the. Did you guys use the PD, like the PowerPoint slides? Were you guys using those with the videos? Were those helpful? Do I even need to put those on there? I see a nod from Aaron. I guess it's a yes. Timothy, give me. Okay, all right. So I'll do that then. I'll do what I did last semester. I'll have the PD or the last module. I'll do the PDF and the PPT, the PowerPoint, just so you guys can zoom into the images and use some of those images, so you guys can take notes. But like I said, if you come out of this one unit and you don't know anything about like muscle tension or like is this concentric, eccentric functioning, we're going to be hammering the heck out of this because this is what's going to make or break it towards the end of the semester. With that said, I have down here these 3 documents: muscle contraction, muscle control, and these movements with muscles, right? And let's start with this flow chart here. This is from one of the lecture slides, but it basically, oh, you're going to do that to me, aren't you? Okay, perfect. Let me open it up. All right, so we have red light, green light, and yellow light. So if we all drive in the United States, we know that red means stop, green means go, and yellow means slow down and put the, you're starting to put the brakes on. And that's basically how muscles function. Muscles are either on, and if they're on, they're generating tension. And when we say that a muscle's on, we say that's muscle contraction. And it's generating tension. Now, the movement, the actual joint action that occurs, will vary based on how much tension the muscle generates compared to what the external load is, right? So when you look at the types of muscle action, this really should be joint action, but muscle contraction, you either have isometric, which is no movement, right? Iso meaning same length, so the muscle length isn't changing. So if the muscle length isn't changing, there's no joint motion happening, or indiscernible joint motion is occurring. Or you have isotonic, meaning that there is some change, some movement. Now that change can either be joints are getting closer together, like adducting, internally rotating, or flexing, or joints are getting further apart, like extension, abduction, or external rotation. So it's using the terminology we used before from the previous unit. And if there's muscle tension, and that's a key word, muscle tension, and there's joint motion, or actually, I should say the opposite. If there's joint motion and there's muscle tension, and it's shortening, it's a concentric contraction. If there's joint motion and there's muscle lengthening, muscle tension, it's eccentric contraction. So that's the quick and dirty way to determine what type of joint motion. If there's no change in motion, it's an isometric muscle contraction. If there's muscle tension, if there's shortening, like the 2 joints are getting closer together, or the muscle's shortening, that's a concentric muscle contraction. And if it's muscles lengthening or the joints are getting further apart, it's lengthening, it's an eccentric contraction. That will get you through your high school anatomy or your base level anatomy class if you just memorize that, right? Where this won't be applicable, where you can sometimes get deviations, particularly as you move on into your career. And for this class, that would solve about 70% of the questions. So if you memorize it just that, you're at a good starting point, but it might be deficient 30%. If you go the next level and you think about the movement aspect, right? Am I preventing motion, right? There's some external force and I'm preventing that from happening. That means I'm generating some muscle tension and there's no movement. That's an isometric contraction, prevention. Think of the stop sign. If I'm accelerating, So I'm overcoming gravity, or I'm overcoming the direction of resistance, or I'm moving faster, like I'm somehow overcoming gravity, whether I'm moving against it or I'm moving faster than that. Acceleration, that's always a concentric contraction. And then if I'm moving slower than gravity or moving slower than my external resistance, so someone's pushing me and they're pushing me at 7 miles per hour, but I'm only moving at 4 miles per hour, that means I'm giving them some counter resistance. Or gravity wants to pull my arm straight down, it just wants to drop, but I'm moving it slowly down. There is some braking force that's happening there. That's an eccentric muscle contraction. You will 100% of the time get the answers correct. If you think of it from not change in length, but in terms of are you stopping, accelerating, or decelerating, it will cover everything, and it expands your concept of that. For instance, with the lengthening, if I just say that my arm is coming down here in elbow extension, I can say that this is moving, this is shortening, and this is lengthening, right? So I can say that that's an eccentric contraction, but this is, in order to be a contraction, you have to have a go signal from the nervous system telling that muscle to generate tension. So me just doing a movement here and, oh, hey, my tricep is shortening. Yes, it's shortening, but it's not doing it under tension. You could easily say, hey, that's a concentric contraction. This is an eccentric contraction. But contractions can't happen at the same time. You either have a muscle that's on as an agonist or have a muscle that's off as an antagonist. And the way that the body works, muscle and muscle function only works from generating muscle tension or a pulling force. Muscles cannot push. So if I have this water bottle and I take this and I move it this direction, I pulled it that direction. In order for this to reposition, so this was, let's say, flexion, in order for me to go back and reposition to extension, there's nothing that pushes me there. Only something on the other side here can come back and pull this back in this direction. And I can pull it further that direction in order to reposition back to center. This doesn't push this way. This pulls in this direction. So all muscles are paired in this tug of war type function, right? So whatever can extend, you have another set of muscles that can flex. Whatever can abduct, you have another set of muscles that can adduct. Whatever can dorsiflex, you have another set of muscles that can plantar flex, right? Sometimes those other muscles do that. Sometimes gravity does that, right? So if this is my foot, all right, let's just use my hand here. If I do finger extension there, in order to get back down into flexion, I don't need to recruit my flexors. Gravity is already pushing me down. I'm just under the effects of gravity, right? Now, if I move this speed where gravity is just coming down, and I move slower, now I've done an eccentric contraction. If I've just let gravity take over, that was no contraction, even though muscle length occurred. So you see there's different scenarios. And if that didn't make sense, it's okay. If you start watching the videos, we'll go through. The point of today is just to start introducing these concepts, and it starts with like length change, right? No change in length, shortening, lengthening. But the better way of thinking it is, am I resisting motion, stopping motion, no motion is occurring, so I'm controlling that or preventing that. Causing motion, aka acceleration, right? This is overcoming gravity, and this is eccentric, going with gravity, slowing things down, overcoming gravity. Now, example where you can have the exact same joint motion and one can be concentric, one can be eccentric, is if I had you take like a piece of paper or an eraser or something, and I had you stand up, and I had you just bring your arm down, right? So you're standing, you're producing elbow extension, right? And you look at the speed at which your hand is moving versus the speed at which you drop something. And just a real quick physics review that no matter if this was a pen or a bowling ball or a brick or a car, would all drop at the same speed, right? So mass is irrelevant in terms of how fast gravity, the acceleration of gravity, right? Now, the impact, if I try to catch the pen, I'm going to be okay. If I try to catch that bowling ball or that car, I'm toast, right? So whether it's going that, so that's the speed of gravity. So if things are moving slower than that, that means there's an eccentric force that's slowing it down. What about if things are moving faster than that? Is there a way that I can take this pen and make it move faster than gravity towards the ground? Yeah, I would take it and I would actually slam it down towards the ground. I would accelerate it down. So the two situations, me just holding the pen and slowly putting my hand down, I'm standing doing elbow extension. That's a eccentric function of the elbow flexors because they're putting the brakes on, right? If the gravity is this direction trying to put down, that means I have something moving up So my elbow flexors would be working. And now if gravity is in this direction and I'm trying to go faster and I'm slamming it to the ground, that would be the concentric activity, still elbow extension, same joint action, right? What you saw is what you get, but now it would be another set of muscles on the other side, and they are slamming that down to the ground. So it would be a concentric function of the elbow extensors working concentrically, right? And then the isometric example would be me just standing here and gravity's trying to pull this down. The muscle tension is equal to the gravitational force pulling down, and so there's no movement. Isometric. That's a contraction of the elbow extend or elbow flexors. If my elbow flexors and my elbow extensors, so both paired muscles, contract at the same time, then you'd get a situation where if like you're going to try to make a muscle, right? If you make a muscle, I try to make a muscle here, people think you're trying to flex your bicep when you do that. But when you make a muscle and I'm not moving, right, I'm just contracting, my bicep, I'm trying to contract my bicep as hard as I can. The reason why I'm not punching myself in the face is because my triceps are also contracting as hard as they can, trying to prevent that arm from, so the triceps are trying to pull this way, the biceps are trying to pull this way. Their forces are equal, and I'm able to make a muscle then, right? So that just kind of shows the example of elbow flexion / extension. In this case, we're looking at elbow extensors isometrically, concentrically, eccentrically. And it's easier to look at it from this way in terms of preventing, causing, or stopping motion than it will from that. So that's really the basis of that. And when we go through the videos, they take you through more examples. They kind of go through the aspect, but this is Unit 2 distilled down into one infographic. Any questions on this? Okay, and then so the next file in here is this muscle control formula. And we're not gonna go through it just yet, but I do want to let you know that there is this document here that is very helpful. So it's basically a stepwise process, the next phase of our movement analysis. So before I gave you an exercise and you had to identify the plane of motion, or you had to identify the joint, which joint was moving, what plane of motion was it moving in, what the joint action was, flexion, extension, abduction, and what axis of rotation. This is the next step in the evolution of our analysis, which is now the next two steps is it a product of with gravity or against gravity? So it's an acceleration, deceleration, or controlling motion. And then the final step is what muscle group is participating, right? So we're looking still at like the elbow flexors or the abductors. And then after this unit, when we get into each of the body part regions, then we'll add it to the final step, which is which muscles are there. So we say elbow flexors, and okay, now that's biceps brachii, brachioradialis, right? So it's going to be the next tier of evolution. This is copied and pasted from a textbook. So this is like the exact terms that you use. Like it's like the technical aspect, but it can be a little overwhelming. I did it for a Blackboard announcement for my other class, and I'll just post it over here. I basically reduce it down to a 3-step process, and it kind of incorporates this right here, right? It kind of incorporates this flow sheet. And now that I'm thinking about out loud, I should do a visual flow sheet for that muscle control. And I will create that this week because I think this is a good idea. So basically what you're doing is, these multiple steps. You're doing what you did before, where you did your, what joint is moving, what plane. And I gave you that example with the bicep, with the elbow extension, that it had 2 different muscle outcomes. That's the only variation that occurs. What you see for joint motion is always what you get. It never changes. So if you see elbow extension, no matter what plane I'm in or what position I'm in, it's always elbow extension. If you see internal rotation, it's always internal rotation. Now the plane might be different, right? But elbow extension is elbow extension. Cervical rotation is cervical rotation. Neck flexion is neck flexion. It never changes, right? What changes is the orientation to the resistance or to the load, right? To the force, to gravity. So in this case here, I'm doing elbow flexion that's with gravity. So that would be a concentric action because I'm overcoming gravity. And in this case, I'm doing elbow extension, but I'm doing it with gravity, moving slower than gravity. That's a product of eccentric muscle function. So before it was just you were looking at joint. Now you have to determine whether it's flexion or extension. Is it abduction, adduction? And now is it a product of, and the next step here, which is reducing all these steps down into the next step, is just observing, am I going with gravity or am I going against gravity? And if gravity isn't your resistance, like if it's, because 95% of the time, like when you look at free weights and body weight activities and sporting events and so forth, gravity is the resistance. That's what we're always overcoming. If you're using cables, all you're doing is redirecting gravity, but it's still the weight stack that you have to overcome. And when you get into like these 2 or 3 other odd things like elastics or tubing, or water or momentum, there's other forms of resistance that can also. So when you're dealing with elastics, it's the elastic that's generating the resistance, right? Not the gravity, because elastics have no mass. If I ball up the highest like gold double plus extra black, whatever your most highest tension elastic band is, and I ball it up and I throw it right in your face, you're probably going to just yell at me and call me a jerk. But if I take the same heaviest resistance, like a 100-pound kettlebell, and I throw it at your face, you're probably going to die, right? So there's no mass to the elastic. So gravity doesn't really have an effect on the elastic. The elastic itself is just on its tension it generates. So when you're dealing with, when I say gravity, what I really mean is when I say you're overcoming gravity, the question really is, are you overcoming resistance? So if you're using like cable or elastics or water resistance, it's going to be a different, it's not going to be down, right? The resistance is going to be a different direction. But the next question you ask yourself is, am I going with the direction of resistance or gravity, or going against it? If you're going with it, if you're going against it, right? So you're overcoming it. You're trying to overcome the resistance. So I'm trying to extend that tension of that elastic band. I'm trying to go up with my movement. Even though I'm pulling down with the lat pull down, that weight stack is still going up. I'm trying to overcome gravity. No questions asked. It's a concentric activity all the time. Then the next aspect is, okay, I'm going in the same direction of the resistance. So I'm going in the direction that the elastic is trying to pull me. I'm going in the same direction that gravity is trying to pull that weight stack. I'm going down towards the ground in the bottom part of my squat. So now you're going with gravity. Now you're going to be possibly, most likely, an eccentric activity, but that you have to ask yourself a secondary qualifying question. Am I going slower than the resistance if I just let go, or I just let gravity take over? Or am I going faster than that? If you're going slower, that means you're putting the brakes on. You're creating a counter resistance because it wants to pull you at this speed, but you're going at this speed instead. That's an eccentric function. If it's faster, which most of the times it's going to be a sporting event like a medicine ball slam or some kind of like explosive movement, but that's usually when you're going to see those. If you're moving faster than gravity, then it's back to the overcoming gravity concentric. So those are your options, and I'll create a flow sheet for that. And I think I kind of, in one of the videos, I do have a flow sheet quasi started. So I'll just kind of, I'll extract it from one of the slides from the PowerPoint. But it's basically the next step. Instead of all these 6-step questions, just ask, is the movement happening with gravity or against gravity? If it's moving with gravity, then is it moving faster or slower? And that's your flow sheet there, right? So if it's not moving, it's isometric. If it's overcoming gravity or moving faster than gravity, it's concentric. And it's moving slower than the external resistance, it's eccentric. Sounds simple, sounds easy, but it gets convoluted when you start to try to analyze movements and going through there. I can do an example. We'll do one example and then I'll leave you to it because I don't want to give you too much without you watching the videos first and kind of going through, because I think once you watch the videos, it'll make a lot more sense, give you some practice. And then all we're really going to do in our live sessions is we're going to do practice. We're going to practice, do practice examples, and I'm going to drill this into your head because I did some changes this first exam that I think was purposely gave you guys more higher percentage, and I want to shoot for that. I want to see if I can get you guys above 70% again in this exam. If I can get you guys to 80, 81%, we're going to be golden for the rest of the semester. So cool. All right, so if we look here, let me actually pull up my marking tools. Okay, so we have the biceps curl, right? And so our very first step is to identify the joint action. And what we see here, and what we're doing is we're moving, here's our starting, come on. Hold on, let me just close this out and open it up again. Let's see if this makes any difference. Well, my marking tool is not working right now. So let's see if I do this. All right, well, I can't mark it up, so I apologize for my, but we'll just go from here. So we're going from left to right. We're starting in this position here, and we're going to go to this position there. And so what joint action do we see happening from left to right? We see elbow flexion occurring in the sagittal plane about the medial lateral axis. So good, that was unit 1. Now unit 2, first part, was this movement going against gravity or with gravity? Well, gravity is always down, and I moved up, so I overcame gravity. I was going against gravity, so that's a concentric function. Okay, so now great. Next step is which muscle groups were involved. And as of right now, you don't need to know individual muscles. Just realize that muscles are typically, or not typically, are named for their concentric function, right? That's how we learn from anatomy, and we still carry that over. So in this case, this was a concentric activity. These were the elbow flexors working concentrically. Perfect. That's it. Now my reposition, this is my starting position, and I'm going from right to left. I'm going from B to A. What joint action did I see? Well, what comes up must come down. So if I flexed and now I'm going back to my starting position, that's extension. Did I go with gravity or against gravity? You went with gravity, so in the same direction of gravity. Unless otherwise specified, it's assumed that it's under control, right? So unless it says explosively or as fast as you can, if it doesn't say, it implies that it's going controlled. So that's slower than gravity, right? So if I just let that bar drop versus me bringing it down to my side, that's with gravity, slower than gravity. Is that concentric, eccentric, or isometric? It's an eccentric function, right? So that's elbow extension working eccentrically. What muscles are working here? So muscles are named for their concentric activity. So if this was eccentric, it wouldn't be elbow extensors. It would be the opposite. It would be the elbow flexors working eccentrically. And think about it. When you do this exercise, you already know inherently what muscles you're using, right? You're using your biceps. You wouldn't say, I'm using my biceps on my way up and my triceps on my way down. You would if you tried to throw that bar to the ground and try to smash your feet. Then that would be a concentric function of your elbow extensors. But if you said eccentric function of elbow extensors, that means your triceps are working to slow things down, and your triceps are actually totally off, right? Because if your triceps did get the go signal, they would slam that down. So your triceps aren't getting any contraction whatsoever. What's happening is your bar is going down, gravity's trying to pull you down, and you are putting the brakes on. So you're creating a force that is in the opposite direction. That's going to be the elbow extensors. I'm sorry, it'll be the elbow flexors working eccentrically because they're lengthening. Even though they're generating muscle tension, gravity is winning the tug of war and they're lengthening. And on the way up, the muscle tension was winning the tug of war because they were overcoming gravity, and concentrically, then eccentrically, then concentrically. Okay, so the joint motion switches, but 9 times out of 10, if you're dealing with the sagittal plane or the frontal plane, so you're in the direction of gravity, the same muscle group that was concentrically is going to be the same muscle group that was eccentric. And if you memorize anything, just memorize if you identify that joint motion is a product of an eccentric activity, Just memorize it's the opposite joint function that you see. So if you're seeing internal rotation and you said it's eccentric, okay, internal rotate, it's the external rotators that are working eccentrically. If you see adduction and you identify that it's eccentric, it's the abductors working eccentrically. If it's a concentric function, what you see is what you get. If you see hip flexion, oh, it's the hip flexors. If you see knee extension, it's the knee extensors. If you've identified that it's a external, I keep on getting the words. I'm sorry. You identify that it's an eccentric function. Just automatically just go opposite of the joint action you see. So you saw elbow extension eccentrically, elbow flexors eccentrically. If she goes down into a squat, I have a squat here somewhere. Yep. Okay, I see from here, I see hip flexion. That's a product of going with gravity. So I'm going slower than gravity. That's eccentric hip extensors. Do not say hip flexors, right? Because the only way the hip flexors would be working here is if his feet were strapped to the ground and he was trying to pull himself to prevent him getting hit in the face with that 100-pound kettlebell that I'm throwing at him. All right, so I'm going to leave you guys with that. I think that's a fantastic starting point. It not only is it the starting point, but it is the primary thing. If you come out of this unit just understanding this, you are golden, right? So I have some other supporting things in there. Go through those videos. Like I said, it's about 40 minutes worth of video. I have some of the neurological stuff I have ported over from my KN 230. Those are longer videos. They cover more than we need to for this exam. Start with the muscle stuff, and then I'm going to try to I'll probably create a new video just to reduce it down specifically for these chapters. But if I don't get to that, if you get through this and you're thirsty for more, feel free to jump in those videos. But the ones I have, let me just show you what I'm talking about here. So these ones here, 3.0, 3.1, oh, wait a second. Yeah, all these ones at the bottom. So I have, just so you guys know, each folder I have these Professor Dave and Crash Course. These are extra anatomy videos. These are like static. If you need a refresher or you want to kind of get up on your anatomy, not a refresher, but just kind of get up. These are more, these Crash Course videos are fun. I think they're exciting. They're fast, right? These ones are a little slower, but if you need more time, you can go through there. These videos that I put here, I just added these today. These are ones that I'm going to probably update, except for maybe this active and passive insufficiency, but I'll incorporate it in there. But you guys can go through those if you want. The ones that I'm not going to change that I want you guys to know are these 4 videos here. So 2.1, 2.1, 2.2, 2.3, and 2.4. This one's the longest at 21 minutes, and I think this one is 7, this one's 9, and 10, so 20, yeah. So about 50 minutes worth of videos. Fantastic videos. They go through this contraction stuff, and I think we'll be in really good shape. Any questions? Perfect. All right, if you guys want to set up any time to go over your exam individually, let me know. If not, I'll be available during the week, and I will see you guys on Thursday next week.